Assalamualaikum and hi. Now, let's look on how to develop a model in operation research. A linear programming model consists of certain common component and characteristic. There are three important components before we start constructing a model. The first one is decision variable, objective function, and constraint. So let's proceed to the detail about these three important components on constructing a model. The first step before we construct a model is to define the decision variable. Decision variables are the variables that decide the output of the linear programming problem. So the objective of solving a linear programming problem is to find a set of decision variables that will produce the optimal output. So this represents an unknown quantity that we want to determine in order to optimize a specific objective. The decision variable usually represent in mathematical expression such as x1, x2, x3, y, a, or any variable you can use. So this variable is a symbol to represent the unknown quantity of each variable. So this can be manipulated on a certain factor to achieve the best outcome of the solution. This is an example of linear programming problem that we need to solve. Awi has a small bakery that are selling blueberry and chocolate muffins for RM2 and RM3 respectively. Awi need 5 hours to bake muffins before he start to sell them. It takes 1 hour to bake 6 muffins for each type. The bakery has a limited supply of chocolate chip and blueberries. The total chocolate chip available is 20 units and the total blueberries available is 15 units. Awi use 1 unit per ingredient to make the muffin. What is the amount of the muffin that he need to sell to maximize the profit? The problem is about selling blueberry and chocolate muffin. So this is the decision variables that can be written as x1, the number of blueberry muffin that need to sell, and x2, the number of chocolate muffin that need to sell. So this is how you write decision variable. Next is objective function. Objective function sets the goal of the linear programming problem. Usually, objective function is either maximize or minimize the function, depends on the problem, and usually denoted by Z. The objective function involves decision variables. From the problem before, what is the objective of this problem? So the objective is to sell blueberry and chocolate muffin and want to maximize the profit. So we will use this information in the objective function. The price of the blueberry is RM2 and for chocolate muffin is RM3. So how much are we need to sell the muffin to maximize the profit? The objective function for this problem is to maximize the profit of selling blueberry and chocolate muffin. So we can write the objective function as maximize Z equals to 2x1 plus 3x2. Z is the total profit per day from selling the muffin. 2x1 is the profit from selling blueberry muffin, and 3x2 is profit from selling chocolate muffin. Next, we will look about the constraint. Constraints are restriction or limitation placed on the decision variable. They define the feasible region that set the valid solution, which satisfy both the problem's requirement and real-world constraint. The constraints are expressed as a linear equation or inequality involving the decision variable. Each constraint represents a specific condition that must be met. And the final restriction is a non-negativity constraint that compulsory. From the problem before, what is the constraint? Here there are two constraints that we need to consider, which is, we need 5 hours to bake muffin before he start to sell them. It takes 1 hour to bake 6 muffins for each type. The second one is the bakery has a limited supply of chocolate chip and blueberry. That chocolate chip available is 20 unit and blueberry available is 15 unit. So the two constraints for this problem is limited oven time and ingredient availability. We know that Ali need 5 hours to bake muffin. So he only has 5 hours to bake and 20 unit of chocolate chip, including 15 unit of blueberry available for ingredient. So, how to construct the constraint from the statement above? The first one is about limited oven time. So the total hour to bake the muffin is 1 hour of blueberry muffin and 1 hour of chocolate muffin. So we wrote 1 hour of x1 plus 1 hour of x2. However, the availability of oven time is 5 hours. So the complete oven time is 1 hour of x1 blueberry muffin plus 1 hour of x2 chocolate muffin less than or equal 5 hours. So this is how you write constraint. The second constraint is about ingredient availability. Blueberry muffin require 1 unit of blueberry and chocolate muffin require 1 unit of chocolate. However, the availability of blueberry and chocolate is 15 unit and 20 unit respectively. So, the availability of the ingredient are X1, which is blueberry muffin, must be produced less than 15 unit or equal. And X2 for chocolate muffin must use less than or equal 20 unit of chocolate. And the last one is the last constraint, which is the non-negativity constraint. The non-negativity constraint is a final restriction that the number of muffins produced must be either 0 or a positive value. Why? Because it is impossible to produce negative item. So these restrictions are expressed mathematically as x1 is bigger or equal than 0, x2 is equal or bigger than 0. So from the model, we can find the decision variable, what is the objective function and what is the constraint. So we can write a complete LP model, which is maximize z equal to 2x1 plus 3x2, subject to x1 plus x2 less than or equal 5, x1 less than or equal 15, x2 less than or equal 20, and x1, x2 must be bigger or equal 0. So this is the complete LP model for the problem before. So that is how you create a model. Remember that model need 3 important things, which is decision variable, objective function, and constraint. If you have any question, leave some comment below and I will answer your question. Thank you for watching this video.